there are two components in MapReduce. One is mapper and there is, so this map is basically mapper, and then reduce is the job of reducer. Okay, so there are two components, mapper and reducer. Okay, so what mapper does, mapper takes the input record. Okay, so whatever is stored on the disk, it takes that input record. Okay, it extracts the key and value from that record. Okay, what is the key, what is the value? Okay, then it writes the output to the disk. Okay, so the idea in MapReduce is everything, whatever is done, like whatever processing is done, it is saved back to the disk. Okay, nothing is kept in memory. Okay, now the second component comes is MapReduce framework. Okay, in MapReduce framework, it takes the key value pair from the mapper. Okay, it takes that key value, whatever we have stored on the disk. Once that is done, it collects values belonging to the same key. So it's basically aggregating those values which belongs to the same key, and then it again writes the data to the HDFS. Okay, once that is done, the job of reducer comes in. What reducer does, it takes the collection of values and input. Okay, it produces the output, like whatever logic is there. Okay, what kind of evaluation we want to do. Let's say we want to count the number of values. Okay, so you have this key, and against this key you have 5 values, v1, v2, v3, v4, v5. Okay, so if you want to calculate the count, so the count will be 5. So this is handled by the reducer. Okay, once that is done, it is stored back to the HDFS, the file system. Okay, so this is how the MapReduce job execution works. General details: number of mappers equal to number of input files. Number of reducers is configured by the person executing the job, so you can configure that value. Framework use hash of the key to ensure all same keys end up on the same reducer so that the processing is faster. Sorting is done in stages because large data size similar to SS tables and LSM trees. If you know, like there are multiple sorting stages. Once that is done, let's say there are 10 blocks earlier. Okay, so once that is merged, then like from 10, let's say you convert it to 5. Okay, from 5 you convert it to 1, something of that sort. Okay, then the shuffle, mappers writes, this is mapper basically writes output to the file. Schedule informs reducer work is done. Reducers connect to the mappers to download sorted key values for their partition and then do that processing. Now, talking about the MapReduce workflows, there are multiple MapReduce jobs chained together in workflow. Output of one job is user input to another job, which we discussed earlier as well in case of Unix rules. That you try to use that pipe operator basically. Okay, so that you can use input of one job as output to another, because there can be a lot of logic which could be in place, right? So keeping all that logic in a single place could be a burden or like not feasible technically per se. Okay, so what you try to do is first to generate, like you process the input, you produce one kind of output, then you use that output to produce, like do another some kind of evaluation, then you produce another. So that lot of these jobs, I mean, lot of these logics can be chained together, C1, C2, or like T1, T2, where like mode of tasks are there, and then the final output can be again saved to HDFS, and the intermediate states are also saved to the HDFS. Okay,